The sea has always fascinated humankind. Its vastness, its calm, the rhythm of its waves, and its raw power have always reminded us of something ancient, a force that existed long before people appeared. From the shore, the ocean seems friendly, predictable. Yet beneath that fragile balance lies a world we cannot control. A realm where a single spark can awaken something beyond the limits of human imagination, something that embodies the true magnitude of nature's power. Sometimes, there comes a moment when the ocean falls silent. The wind stops, the waves disappear, and the sea pulls back, as if it has suddenly forgotten where its boundaries lie. Those who know its moods understand what that means. Something is coming, something unstoppable, merciless and immeasurable. This is a story about a force without a face, without direction, and without mercy. A story about the power hidden in the depths, invisible until it's too late. Everything begins in silence. Far beneath the ocean's surface, where no light can reach and pressure can crush steel, the Earth occasionally remembers that it is alive. The tectonic plates, gigantic fragments of the planet's crust, are in constant motion, though they shift so slowly that a person might live an entire life without noticing. But when tension builds for hundreds, sometimes thousands of years, the Earth eventually breaks. In a single instant, a fraction of a second, an enormous tremor shakes the planet. That underwater earthquake, which often remains hidden from view, gives birth to something far greater than trembling rocks. The energy trapped within the planet's crust is suddenly transferred into the water. The ocean, massive, heavy, and seemingly unmovable, behaves like a vast elastic membrane. It receives the impulse and begins to vibrate. That impulse doesn't resemble an ordinary wave. It isn't shaped by the wind. It's pure geological force, raw energy that moves millions of tons of water upward and outward. Thus, a tsunami does not begin with a single wave, but with an entire chain of waves, radiating from the epicenter like ripples spreading across water, except on the scale of entire oceans. Out in the open sea, they are almost invisible. Their height may be only a few dozen centimeters, yet they travel at speeds between 500 and 800 kilometers per hour, roughly the same as a passenger jet cruising at high altitude. For sailors crossing the oceans, such a phenomenon often passes unnoticed. The wave glides silently beneath their ships, leaving no trace of warning. Yet beneath the surface, hidden within the water's structure, lies an unimaginable amount of energy. Only when a tsunami approaches the shore does it begin to reveal its true nature. The seabed rises, the water shallows, and the wave's speed drops, forcing all that power to shift upward. The ocean that moments ago seemed calm suddenly begins to rise. This is the moment when the water recedes from the beach, exposing the seabed and leaving behind floundering fish. A deceptive sign of danger that, in many tragedies, became the last sight seen by those standing on the shore. Then comes the wall of water. Sometimes it's a few meters high, sometimes a dozen, and in certain places it has reached 40. It strikes with a force beyond calculation, tearing away houses, cars, entire cities. Every tsunami is different. Some are born from earthquakes, others from volcanic eruptions or underwater landslides. There are even those triggered by meteorite impacts. But the mechanism is always the same. The ocean becomes a messenger, carrying the energy of the planet's interior, as if the Earth itself were reminding us of its power and of how we humans stand upon only a thin crust above its restless heart. When the sea begins to retreat, revealing the wet seabed, fish, and coral, many people, unaware of the danger, treat it as a natural curiosity. It's a deceptive beauty, a silent warning before the catastrophe. From the moment the ocean runs away from the shore to the instant the main wave strikes, there are usually only a few dozen seconds to a few minutes. In extreme cases, just 30 seconds, or perhaps 2 or 3 minutes, but never more than 5. It's terrifyingly little time to understand what's happening, and even less to escape. In such moments, there is no time for hesitation. The sight of a retreating ocean is not an invitation to wonder. It is an alarm. Anyone who sees it must immediately run toward higher ground, a hill, a sturdy building, anywhere away from the coastline. The water will return faster than anyone can imagine, carrying with it everything it meets. Those who have survived a tsunami say the most terrifying part wasn't the impact itself, but the inevitability, that moment of realization when they understood that the sea, which had just retreated, was now returning as a colossal wall. It is in that instant that nature shows us how just a few seconds can decide everything. When a tsunami wave reaches the shore, its true power is revealed only in the final moments. Far out in the ocean, it is nothing more than a gentle undulation, just a few dozen centimeters high, nearly invisible to ships and satellites. But as it approaches shallower waters, the same energy that has traveled thousands of kilometers at speeds between 700 and even 800 kilometers per hour has nowhere left to disperse. The sea slows down, yet its force condenses. It is the collision of the fluid world with a solid one. The entire strength of the ocean compressed into a single wave that rises higher and higher until it becomes a vertical wall of water. At the moment of impact, the wave can reach anywhere from a few meters to as high as 30. In extreme cases, like the tsunami that struck Alaska in 1958, the water surged more than 500 meters high, sweeping away entire mountainsides and forests. Most tsunamis never reach such monstrous proportions, but every single one carries the energy of millions of tons of TNT, and it rarely comes as a single strike. It arrives in a series. The first wave is often just a prelude, while the following ones, taller and stronger, obliterate everything that managed to survive the previous. In those moments, the water no longer resembles the familiar waves of a beach. It becomes a dense, murky wall carrying mud, stones, cars, trees, houses, everything in its path. The force of impact is enough to shatter concrete, move train cars, even demolish entire ports. In coastal cities, the wave rushes through streets with the speed of a racing car, flooding district after district. The sound that accompanies it is unforgettable. A deafening roar, part avalanche, part sea, part breaking wood. It's a sound survivors say they can still hear in their dreams. For anyone caught in the path of the wave, every second counts. Escape becomes nearly impossible. The force of the water can lift and drag away anything not firmly anchored to the ground. The current of a tsunami has immense suction. After the initial strike, the wave often pulls back toward the sea, carrying with it people, animals, fragments of buildings, and entire sections of land. It is not only a destructive element, but also a geological one, capable of reshaping the coastline, shifting river mouths, and carving new bays in mere minutes. And then, silence, the ocean withdraws, but the landscape it leaves behind is unrecognizable. Shorelines are erased, roads and buildings buried under layers of silt, and the air carries the heavy scent of salt and mud. For many people, this is the moment when the true scale of the disaster sinks in. When they understand that what struck them was not an ordinary wave, but the wrath of the ocean itself. A reminder that from time to time, nature rises to show just how small and fragile humanity truly is. When the water finally recedes, the tsunami does not end with its retreat. It marks the beginning of a quiet, drawn-out catastrophe, one whose effects last for weeks, months, and sometimes years. The ocean that arrived in a single furious blow leaves behind not only ruins and mud, but deep scars, etched into both the landscape and the human soul. The first and most visible consequence is the complete transformation of the coastline. A tsunami can shift the boundary between land and sea by hundreds of meters, either inland or outward. Layers of sand, silt and mud blanket fields, villages, and roads, while salt water seeps deep into the soil, killing plants and poisoning drinking wells. In some regions of Asia, after the 2004 tsunami, the salt remained in the earth for years, making it impossible to grow rice or vegetables. Farmers had to start over, not only rebuilding their homes, but restoring the fragile ecological balance of the land their families had cultivated for generations. The seabed changes too. The immense force of the wave moves sediment, gravel, and sand, altering currents and displacing coral reefs. In many places, underwater landscapes that had formed over thousands of years were plowed apart in mere minutes. Some species of fish and crustaceans Those dependent on specific depths or temperatures vanished from their habitats. Others, more resilient, took their place, reshaping local ecosystems entirely. Tsunamis also affect the atmosphere. The water that rushes inland carries with it vast amounts of microorganisms, gases, and organic matter. When the waves withdraw, they leave behind layers of decaying debris and mud that begin to ferment, releasing methane and carbon dioxide. On a global scale, the impact is small, but locally, it can alter the microclimate, increasing humidity, raising temperatures, even attracting new forms of life that never existed in the area before. But the most lasting consequences of a tsunami are not written in the earth. They live in human memory. Coastal. Residents often speak of the roar that never goes, silent. The sound of the retreating water, the crash of waves tearing through houses, the cries of people and animals. These memories linger for a lifetime. Psychologists say that long after the physical wounds heal, survivors continue to experience anxiety triggered by the sea, by the sound of the wind, even by the scent of salt in the air. For many, the ocean that once sustained them with food and life becomes a symbol of loss. Yet, paradoxically, tsunamis can also unite communities. Across Asia, Africa, and South America, devastating waves have led to the creation of advanced early warning and education systems. Networks of seismographs, tide gauges, and satellite alerts now give people precious minutes of warning. Children in schools are taught that a receding sea is not a miracle. It's a signal to run. A tsunami does not only destroy, it reminds. It shows that humanity, despite its technology and power, still lives on a fragile edge between safety and chaos. Each catastrophe is not just a tragedy, but a lesson in humility. A reminder from the planet that we are not its masters, but its guests. After disasters that erased entire coastlines, scientists and engineers began developing systems capable of predicting tsunamis and giving people a chance to escape. It's not an easy task. A wave can travel hundreds of kilometers in just a few hours, sometimes minutes, and every retreating tide may mean another strike is coming. That is why modern warning networks combine knowledge from geophysics, oceanography, meteorology, and satellite technology, all working together to read the language of the sea before it speaks again. The first element is seismology. Tsunamis most often originate from underwater earthquakes, which is why monitoring seismic activity is absolutely crucial. Networks of seismometers positioned across the globe can detect even the smallest tremors beneath the oceans and instantly relay that information to warning centers. Within minutes, experts can determine the strength and location of the quake and assess its potential to generate a tsunami. In just a few moments, scientists can estimate which coastlines are in danger and which may remain relatively safe. The next tool is the system of dart buoys, deep ocean. Assessment and reporting of tsunamis. These small devices float on the ocean's surface or rest on the seafloor, measuring pressure changes in the water. Even the slightest rise in sea level, invisible to the human eye, is immediately recorded and transmitted by satellite to monitoring stations. From this data, scientists can calculate the height, speed, and expected arrival time of a wave long before it reaches land. Satellites and computer modeling are the next line of defense. Using satellite imagery, scientists can track subtle variations in ocean levels, currents, and atmospheric pressure. Data that helps predict how a tsunami will behave along its route. Advanced simulation software can virtually rewind or fast-forward tsunami waves across digital maps, showing which towns and villages will face the greatest danger. This allows authorities to plan evacuations in advance, designate safe routes, and prepare shelters. Yet the most critical, and often the hardest, element is communication. Warning systems are not only about technology, they are also about awareness and education. People must understand what a receding ocean means, what different alarm sounds indicate, and how quickly they need to respond. In countries like Japan, Indonesia, and Chile, evacuation drills are held regularly so that every coastal resident knows exactly where to run and how to protect themselves. Modern tsunami warning systems integrate everything: seismometers, buoys, satellites, computer models, and public communication into one fast-acting mechanism that gives people a chance to survive, where once there was none. Technology cannot stop a tsunami, but it can predict its arrival and save thousands of lives. It stands as proof that science, observation, and rapid action can face even the greatest fury of the ocean. Throughout history, the oceans have produced waves that became legends, not only as colossal natural events, but also as moments that changed the fate of entire communities. One of the most terrifying examples was the tsunami that struck the Sunda Islands in Indonesia in the year 1946. It was triggered by a massive earthquake measuring roughly 8.5 on the Richter scale. The resulting wave reached heights of 10 meters, and in some reports, even 15. Between 200,000 and 300,000 people lost their lives, and entire coastal villages vanished from maps within minutes. The destruction was beyond imagination. Homes were obliterated, farmland was drowned, and shorelines were completely reshaped. Another tragic event was the tsunami generated by the Indian Ocean earthquake of 2004. The quake measured 9 1/10 in magnitude, with its epicenter off the coast of Sumatra. The waves soared up to 30 meters in the hardest-hit areas. The toll was catastrophic. Over 230,000 deaths across 15 countries, millions displaced, and entire coastal ecosystems destroyed. Beaches were ripped from their natural contours, and coral reefs that had taken millennia to form were shattered or buried. That disaster revealed just how delicate the balance between ocean and land truly is, and how swiftly nature can remake the familiar world. No account of tsunamis would be complete without mentioning the disaster that struck Japan in 2011, a magnitude 9. Earthquake off the coast of Tohoku unleashed waves up to 10 meters high, and in some places, 14. The devastation was staggering. Entire cities were submerged, ports and industrial zones obliterated, and in Fukushima, a nuclear catastrophe forced tens of thousands to evacuate for years. More than 15,000 people died, and the environmental and economic consequences are still felt today. Historical records also tell of great Pacific tsunamis in the 18th and 19th centuries. One such event occurred off the coast of Chile in 1819. The waves spread across the entire Pacific, reaching as far as Japan and Hawaii, causing destruction thousands of kilometers from the epicenter. Though exact casualty numbers are hard to confirm, records speak of thousands missing and dozens of coastal villages wiped from existence. These examples reveal not only the sheer destructive power of the oceans, but also the diversity of a tsunami's consequences, from the immediate threat to life, through the collapse of infrastructure, to the long-term ecological and social impact. In every case, regardless of place or time, one truth remains constant. A tsunami is a force of nature beyond human control. Yet it also teaches us that through observation, preparation, and early warning, lives can be saved, even if the ocean's true power can never be fully tamed. The tsunami that swept the world 66 million years ago, the sky over what is now Mexico's Yucatan Peninsula split open with a flash brighter than 1,000 suns. In a fraction of a second, an asteroid 10 kilometers wide tore through the atmosphere, a mountain of rock traveling faster than a rifle bullet, carrying the energy of billions of atomic bombs. When it struck the Earth, it wasn't just an explosion. It was the moment when the planet, for an instant, stopped being itself. The ocean evaporated. The ground convulsed. The air turned to fire. The impact site, today known as the Chicxulub crater, opened like a wound 180 kilometers across and nearly 20 kilometers deep. Around it rose a ring of molten rock, and the force of the collision rippled through the planet's crust like a drumbeat. Earth answered with a wave. First came an earthquake beyond all human comparison. Scientists estimate its magnitude may have exceeded 11 on the Richter scale. The shock traveled through the oceans, shaking the seabed, displacing and lifting unimaginable volumes of water. At the point of impact, where a shallow sea once lay, a wave was born. a wave unlike anything our world had ever seen. According to modern simulations, that wave may have towered 1.5 kilometers high at its origin, a wall of water the size of mountains. It raced outward at nearly 1,000 kilometers per hour, spreading in concentric rings from the impact site like ripples from a stone cast into a pond. Except this pond was an entire planet. The first surge swept across the Gulf of Mexico within minutes. In less than 4 hours, it reached the shores of what is now Florida, and within a single day, it struck the coast of West Africa. The Atlantic boiled. Waves collided, rebounded from continents, and overlapped, amplifying their power through interference. This was not a single cataclysm. It was a chain reaction of chaos circling the globe for days, perhaps even weeks. On the northern shores of North America, thousands of kilometers from the impact site, forests and plains were drowned. In what is now North Dakota, scientists have found layers of sediment bearing traces of that ancient wave. Bands of mud and sand filled with shark teeth, splintered wood, and the remains of dinosaurs. All of it was carried by the water, while the planet was still trembling. But the tsunami was only one act in this global tragedy. Next came the fires, vast infernos sweeping across continents, followed by clouds of dust and soot that blotted out the sun for years. The ocean that had risen like a wall now grew still, cold, and poisoned. Ecosystems collapsed. The dinosaurs, rulers of Earth for more than 100 million years, vanished almost overnight. Yet the water endured. From today's perspective, the Chicxulub tsunami is more than a geological event. It's a reminder of the immense power still hidden in both the cosmos and our own planet. Every meteor crater, every thin layer of iridium buried in ancient rock, is an echo of that moment when nature revealed that human fear can never match the scale of its force. Across the world, scientists continue to reconstruct that day, building digital models, analyzing sediment layers, tracing the ancient flow of water. And each time the simulations run, the result is the same. The wave was bigger than we ever imagined. It wasn't just a tsunami. It was an ocean losing its balance. Compared to that event, every tsunami that followed, even those that claimed hundreds of thousands of lives, are mere ripples in a mourning tide. And yet from that destruction, a new world emerged. From the ruins of the old Earth rose species that adapted, evolved, and flourished. The water that once destroyed life became its cradle once more. Today, when we gaze upon the tranquil blue of the Caribbean, it's hard to believe that beneath its calm surface lies the scar of the greatest wave in history. A wave that swept across the planet to begin a new chapter in the story of life on Earth. Interestingly, a tsunami doesn't always arrive as a single wave. Most often they come in series. The first may be relatively small, while the subsequent ones, higher and stronger, destroy everything that survived the previous wave. A striking example is the 2004 Indian Ocean disaster, where the first wave served as a warning and the following tayetfens of meters-high waves swept across the coasts of 15 countries. Traces of ancient tsunamis are found by scientists in sediments, layers of sand and mud, where fragments of plants, animal bones, corals, or crustaceans are embedded. Some layers stretch for hundreds of meters and show how far the water could reach, thousands of kilometers from the point of origin. This allows researchers to reconstruct the history of oceans and catastrophic events that occurred millions of years ago. Most tsunamis are caused by underwater earthquakes, but nature sometimes breaks the rules. Imagine a wave taller than dozens of stories, generated not by tectonic movement, but by a meteorite impact. Such events are extreme and rare, but they have occurred in Earth's history. But space isn't the only provocateur. A tsunami can also be triggered when a massive block of ice falls into water. Imagine a glacier breaking off from the wall of a fjord in Norway or Alaska. In 1958, in Alaska's Lituya Bay, a huge chunk of a rocky slope plunged into the water, displacing it with indescribable force. The resulting wave reached a record 524 meters in height, taller than any modern skyscraper. Trees and soil were swept away, and the echo of the catastrophe reverberated through the fjord like the roar of thousands of tons of water. Even more extraordinary are scenarios in which glaciers fall into the ocean from high mountains in the distant Arctic or Antarctic. The water is suddenly displaced, forming a wave tens of meters high that can strike coastlines hundreds of kilometers away. Such tsunamis are extremely difficult to predict. There's no earthquake or seismic shock to warn local populations. And then there are meteorites. Any impact of a celestial body into the ocean, even a relatively small one, can generate waves tens of meters high within a radius of hundreds of kilometers. While most of these events in Earth's history remain preserved in sediment layers, computer simulations show that the local destruction would be absolute. Beaches ripped apart, ports flooded, and massive parts of ecosystems carried inland. The bouncing effect, waves that refuse to leave. Not all tsunamis are massive walls of water crashing in from the open ocean. Sometimes nature operates on a smaller yet equally treacherous scale. In enclosed waters, lakes, bays, fjords, the wave hits a shore, bounces back, returns, overlaps with the next wave, and reflects again. This endless bouncing can amplify the water's force in places that seem safe. Norwegian fjords provide a dramatic example of this phenomenon. Deep, narrow, and surrounded by steep cliffs, ideal terrain for rebounding waves. When water is set in motion by a landslide from a towering glacier, the wave has nowhere to dissipate. It crashes into the shore, rebounds, accelerates on its return, and strikes again. Local settlements, once thought protected in the shadow of the mountains, suddenly become arenas of destruction. In these situations, a single moment of inattention can cost lives. For fjord inhabitants, the danger isn't just the first wave, but the entire dance of water that can last minutes or hours. The wave may rebound dozens of times, each time strengthening its impact. And even if it's not gigantic, its destructive power is concentrated in a narrow channel. This is an example of how a tsunami can take a form we don't expect at first glance. It's not always an oceanic wall of water. Sometimes it's a subtle, treacherous force that teaches us that nature knows no limits to its imagination.